Hey everyone, welcome back to our YouTube channel. In today's video, we are going to dive into an interesting coding problem involving matrices. So we will be exploring how to extract the anti-diagonals from a square matrix in Java. So let's get started. Now before we dive into the code, let's understand the problem. In this question, we are given with n cross n square matrix and our task is to extract and print its anti-diagonals. But what exactly anti-diagonals means? So in the question it is given that in an element anti-diagonals of ij, surrounding elements will be this and this. So we can say that it's like a diagonal but it runs from top left to the bottom right. Let's look at the given example to have some more clarity. So let's take the second example where the elements of the matrices are 3, 2, 3, 4, 5, 1, 7, 8, 9. This is a given matrix. Now we have to find all the antidiagonals in this matrix. So we will break this into two parts. At first, we will traverse all the elements present in the top left corner of the matrix. And when we are done with them, we will traverse all the right bottom corner elements of the matrix. This is how we will get our desired output. We have to traverse the matrix like this. For each iteration, we will traverse like this and print the element or return the elements, whatever the question asks us. So first time when we will traverse, we will get 3. Then we will get 2 and 4. Then we will get 3, 5 and 7. Then we are completed with our top left corner elements of the matrix. Now we will traverse the bottom right corner of the matrix. So in this iteration, we will have 1 and 8, and lastly we will get 9. So this is our desired output, you can see. Now let's jump into the code. We want to achieve this program with the time complexity of O(n) square and the auxiliary space complexity O(n) square. I will go through each part of the code. At first, let's take an array to store our result and a variable to keep track where we are in our result array. So let's start. Int array, let's say result equals new int of size n cross n, because we have to store all the elements present in our given matrix. Let's take n equals the length of the matrix, not length. Now we will take a variable to keep an eye on the index in the array. So now we have to traverse the top left corner of our given matrix. So for that we will take a loop. It will start from 0th index till the size of the matrix or the row size, number of rows present, and it will be increased by 1. Let's take two variables, rows and columns. Column will be equals to I. Let's see the example again. So when I was 0, so if we see the first iteration, that is when I is equals to 0, we have printed the element which is present in 0, 0. So our row was 0 and column was 0. So let's write that row was 0 and column was 0. In the second iteration, we have printed 2 and 4. So the row was 0 again, but the column is updated by 1, which is the number of iteration. In the second iteration, when I is equals to 1, our row was again 0, but the column was 1. See, this is 0, 1. So we can see that the column is changing itself according to the number of iteration. When I is equals to 2, so for the third iteration, this one, we have printed 3. So here the row was 0 and column was 2. So when I equals to 2, our row is 0 and column will be updated by the value of I. That's why we have taken row is equals to 0 and column equals to I. So in the second iteration, we can see we are printing two values, that is 2 and 4. So to achieve this, we have to reach in this index of the matrix. So how we will do that? We have to increase our row and decrease our column. Then we will get here. So it is 1 comma 0 index. Let's take the second iteration example. We are printing three values here. So at first we are at 0 comma 2. To reach here, we have to increase our row by 1 and decrease our column by 1, which is 1. So we will go to 1 comma 1 of the given matrix, which is this, and return this value or print this value. And at last we will again increase the value of r by 1 and decrease the column value by 0. So it will come 2 comma 0, that is this index. So 7 will be returned. So what we can see is we have to keep on increasing the row value and decreasing the column value till column is greater than equals to 0. So let's write that in our code. While column is greater than equals to 0, in our result array, in the index position, we will add value of the matrix at row and column position. And after adding each element, we are increasing our row and decreasing our column till the column gets equals to 0. So let's do that. We will increase our row after adding the value and decrease our column. Similarly, after entering each element in our result matrix, we will increase the index also. So this part of the code will help us to traverse the top left corner of the matrix. Now we will write the code for the bottom right corner. For that, we will run a loop from I equals to 1, I less than n, and I will increase by 1. So here why we took 1? Because we have done with our top left part. Now we have to increase our row by 1 because we will start our iteration from this row, and also we will decrease our column by 1 because this is already printed, right? And this index is also printed. So we will increase our row by 1 and decrease our column by 1 also, column size by 1. So we have done this, and let's take a variable row to keep an eye on the row, and column, which will be equals to n minus 1. We have to decrease it as I have shown. Here the column value will decrease. At first it was n, now it will become n minus 1, and row will be starting from ith index. Now we have to run a loop again to print these elements. We can see in our fourth iteration 1 and 8 is printed, and in the last iteration we have printed 9. So how we are achieving this? So if our row is initialized as I, which is 1 in first case, so it will start from this index, right? Our iteration will start from this index, which will print 1 for the first time, this value. So how we will get that? We have to increase our row by 1, so we will get 2, and our column will be decreased in this scenario. So at first our column was 2, now we will come to the first column. So if we see, this is our second row first column element, so we have printed 8. We will run the loop till the row is less than the size of the matrix, in our case which is 3. So we see that our row is 2 by now, so it will stop iterating. In the next and the final iteration, we have seen that 9 is printed. So for the last iteration our row will be 2 and column will be n minus 1, which is 2, and we will return the element present in second row second column of the matrix, which is 9, this one. So we have printed 9. So this is how we will get this. Now let's code this part also. While our row is less than n, we will iterate and we will enter the value in the index position of the result array with the value of matrix at row and column index. So we have entered the value, then we will increase our row and decrease our column, and after entering the value in each index we will increase the index value by 1. This is how we will get the right bottom part of the matrix, and at last we will return our final result. So this is all about the code. Let's compile it. So it is compiling. Let's submit the code. And it's working absolutely fine. I hope this video was helpful in understanding the coding problem. If you have any questions or suggestions for our future video, feel free to drop them in the comments below. Don't forget to like this video, subscribe our channel and hit the notification bell to stay updated with the coding tutorials. Thanks for watching the video. Happy coding guys.